L'Hopital's rule. L'Hopital's rule is a rule about limits. Not derivatives or integrals for a moment, but limits. If you have a limit, x is going to a real number a or it's going to plus or minus infinity, it doesn't matter. You have a limit of something divided by something else, and they are both going to 0, or they are both going to infinity or plus or minus infinity. It doesn't matter the pluses or minuses. If they're both going to 0 or both going to some kind of infinity, then this limit is the same thing as the limit of their derivatives. Now, we're not using the quotient rule. We take the derivative of the top separately, the derivative of the bottom separately. Basically, it's saying that the limit is the same as, it depends on how fast the top and bottom are going to 0 or going to infinity. And this little equal sign with the h over it is pronounced equals because of L'Hopital's rule. It's an abbreviation. This little h refers to L'Hopital. Anyway, let's do an example. Suppose you have the limit as x gets really close to 2 of x squared plus 3x minus 10 over x squared minus 5x plus 6. Now, if you think about this, the top is going to 4 plus 6 minus 10 is 0. The bottom is going to 4 minus 10 plus 6 is 0. It's going to 0 over 0. So the question is, which one is going to 0 faster? Or how fast are they going to 0? By L'Hopital's rule, because it's going to 0 over 0, this limit is the same thing as the limit of the derivatives of the top and the bottom. Now, the derivative of the top is 2x plus 3, and the derivative of the bottom is 2x minus 5. So this limit, which we can't plug in because we get dividing by 0, that's why you can only think about dividing by 0. You can't actually plug in 0. But this one you can. 4 plus 3 is 7, over 4 minus 5 is negative 1, 7 over negative 1 is negative 7. That's the answer. 0 over 0, undefined, those are not the answer. It's actually getting very close to negative 7. Now, we saw these before in Calculus 1. In Calculus 1, we would have taken this and we would have factored. The top factors into x plus 5 times x minus 2, and the bottom factors into x minus 2 times x minus 3. Really powerful trick. If plugging 2 into something makes it 0, there is an x minus 2 in one of its factors. So when you try factoring this thing, you know that. Anyway, we're not actually plugging 2 into this. We're plugging really close to 2 into it, which means that x minus 2 is not 0. It's the same as this x minus 2. We can cancel those out. We get x plus 5 over x minus 3. You plug in 2, you get 7 over negative 1. Negative 7, just the same.